Hi guys, my name is Kate and I worked with Chris Pike this summer and the solar program. One of the unique things about mine is I didn't have like a super niche big project, but instead kind of like worked on a bunch of different aspects of the solar program. Um, so yeah, basically like community solar was what this internship was kind of decided to be at the beginning, but that looks a little different each year. So we'll just go through some of the smaller projects that I did this summer. So basically the solar program continues to expand. Kind of when solar was in its infancy, it was really concentrated on what was called the Sun Belt, which you can see on the map here. But as the price has dropped over time, it's become a much more popular alternative, even in as northern latitudes as Alaska. So basically some of my goals this summer were to manage the UAF solar test site just down the road. So I went out there every week, did some maintenance. I also did some solar degradation testing with Rich when he was here right at the beginning. I started a preliminary solar tilt study here in Fairbanks comparing flush mounted systems and high tilt mounted systems. I also looked at modeling snowdrifts and how that pertains to large solar arrays. And my main big project was the ground temperature monitoring system for the solar array up in Cicilio. The solar technologies program at ACEP is again continuing to expand kind of with solar in Alaska. And they have a lot of specific goals, most of them focused on acquiring more and more data and testing new technologies, because as we know with pretty much all these projects, stuff in the lower 48 can't just be kind of copy and pasted up here. And so there's a lot of potential, but some of the infrastructure has to change. It's also community focused, which I'll kind of talk about later. So the first thing I want to talk about that I spent once a week, I would go out to the solar test site. There's 3 major sections at the test site, which you can see that bottom picture is our weather station. And then there's 2 different sections of solar panels, which actually aren't in the pictures, but there's south facing both monofacial and bifacial panels. And there's also vertical east-west, which is really where a bulk of the data is hoping to be acquired in that east-west facing. That graph at the top, you can see the blue represents those east-west bifacial panels, and the red represents the monofacial panels that are just at the south at the summer solstice, which, as you can see, the bifacial provides a lot more potential for production, which isn't really something that is looked into in places that doesn't have as long sun generation as Alaska. So yeah, we're also in those weather stations. There's a ton of pyranometers. There's an albedometer. We're collecting a variety of irradiance and meteorological data, which also kind of ties in to what Sarah and Adrian were talking about. Like there's just, this test site is just producing tons of data all the time. So then right at the beginning, I worked really closely with Rich, looking at solar panels just around that we had at ACEP at the solar test site, and then actually on the utility scale at GVA. And we were able to inspect them visually, did some thermal imaging and IV curve tracing, which was a really great way to kind of just like throw me in right at the beginning. So I understood exactly the mechanics of how these solar panels worked and what happens over time. Cold weather degradation is a huge thing that is like just beginning to be researched. So that was also like Alaska provides a really unique spot to look into that. So then the main time that I spent here was on a Kotzebue ground temperature monitoring system. So this is actually the picture in Kotzebue at the solar array. They have just under 0.5 megawatt there now. And the initial request actually came from KEA, the electric association up there, because basically what was happening as the ground is shifting and moving, these panels were getting jacked and heaved. And they weren't really sure how to mitigate those issues. So they had some desire to understand what was happening under the ground. When was it freezing? When was it thawing? Kind of what were the temperatures? So we started with this idea that actually was inspired from CCHRC. So I worked really closely with them and developed these thermistor strings, which you can see on that table laid out. Basically what happens, a thermistor uses Ohm's law, which we talked about the very first week. And basically, since you send a known voltage and a known current, then that little black bead in the picture on the left has a specific resistance. Now, each of these thermistors have a data set that will tell you at what resistance is what temperature. So basically, if we know the resistance, then we can know exactly what temperature is monitoring. So this is just kind of the process of, I started basically from scratch, ordering cable, cutting it open, attaching these thermistors, soldering them on, and then doing everything I could to waterproof them. So then we were actually able to go up to Kotzebue at the solar array and install these. We had 3 different strings, and it took us about 2.5 days of being out in the field with mosquitoes. You can see kind of the challenges of field work that I was exposed to. We dug these holes and then they would just continually fill with water as we're trying to put PVC down. But it was really cool. This is the final, what the thermistor strings actually looked like. You can see the drill bit that I'm holding. That's how far down we actually were able to drill into the permafrost, which was really awesome. And in that picture, you can see like these giant chunks of ice were just coming up at the end, which was really, really cool. So these are some of the results. All of the strings worked and they were all waterproof, which is huge. And so you can see those are a screenshot of live results over there. And then this graph kind of just shows preliminary temperature data. So the blue is the panel temperature just of the data logger. So that's like the outside air temperature, which makes sense that it's pretty aligned. That orange is just the ground level. And you can kind of see as the sun gets higher in the sky, warms up the ground, it warms up a little bit. And then even the gray is just 2 feet down and then it goes down from there. But you can see like how drastic it is that temperature drops so quickly. So our goal with this is it's going to be out there for, at least a year, maybe more, and then we can get some data over time. Some of the challenges that I didn't necessarily anticipate were kind of some of the parts that aren't as sciencey that you think of, like, I spent 4 days researching what to order and then trying to order it and getting it shipped to Alaska and stuff like that. And then obviously also the field work, like drilling into permafrost, was no small feat. So I would say to approach later, definitely something would be spend more time at the forefront thinking about Campbell Scientific and the data loggers, because that was something I was really unfamiliar with. And I also had kind of wished by the end I was in such a routine that I wish I had just done more, so we had more strings available, because you put so much work in at the forefront. But now there's enough documentation that I'm hoping that we can build more thermistor strings. They're relatively inexpensive, and we can do more monitoring. And then obviously looking forward having the actual data collected and helping KEA with that. So yeah, it was awesome, super successful. I also just in general have a much greater awareness of kind of solar as a whole and that as a resource in Alaska, and a much bigger appreciation for the potential and the importance in gathering data to expand that potential in the future. Any questions? Yeah.
Does this make you want to tinker with your own solar systems, or have you done that in the past?
Yeah, so I have a little converted van that I built that has my own solar system. And I think definitely especially the time that I spent with Rich, I would say I'm more aware of kind of how those solar panels are potentially degrading, and more aware of the actual mechanics kind of behind the black box idea. And so I think there's definitely things I would have changed with that system had I known some information.
Very cool. Let's get another round of applause.
Yeah.